Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and today we continue with our topic of discussion, and we are discussing structure and bonding. So up to this stage, we have learnt about ionic bonding, which exists between a metal and a non-metal through a transfer of electrons. And also, we discussed covalent bonding, which is between two or more nonmetals through sharing of electrons. Then we've had diagrams to illustrate each situation, and also we have explained the properties of the structures thereof, or the structures that are obtained in both cases. So at this point, we'll discuss the third type of bonding, and this is metallic bonding. And this is the type of bonding that exists within the structure of a metal. Within the structure of a metal. Most learners confuse this and say that this is the bonding that occurs between a metal and another metal. That is not true, or that is wrong. So it is not correct to say that a metal bonds with another metal. What actually happens is that the atoms of a metal, they bond with each other by use of metallic bonds to form the structure of a particular metal. So you can say that this is the type of bonding within the atoms of a metal. Within the atoms of a particular metal. Let's say magnesium metal. Within the magnesium metal, the atoms inside there, they are bonded by metallic bonds. And here, what happens is that the positive or the positively charged nuclei, where we have the protons, attract electrons from the surrounding atoms. The positively charged nuclei attract electrons from the surrounding atoms, forming a mobile sea of electrons, a mobile sea of electrons that are delocalized. So the nucleus or the nuclei are positively charged. The many nuclei of the different atoms, they are positively charged. So they attract electrons from different atoms so that they are surrounded by the electrons. And that's what we call a mobile sea of electrons that are delocalized. And this is as demonstrated here. So we have the many positively charged nuclei. So these are positive nuclei. And then these positive nuclei are surrounded by a mobile sea of electrons that are delocalized. So we have positive nuclei, and we have the mobile sea of electrons. The mobile sea of electrons that are delocalized. They can move. So this is a metallic structure with many positive nuclei in a mobile sea of electrons that are delocalized. So based on this, we are saying that we'll have the following properties of metals. Metals have the following physical properties as a result of this type of bonding. One, they are good conductors. They are good conductors of heat and electricity. They are good conductors of heat and electricity in solid and liquid state. And you can say that this is due to the presence of delocalized electrons. So the mobile sea of electrons that you have seen within the metallic structure are delocalized. Number two, metals have high melting and boiling points. Have high melting and boiling points. And this is because metallic bonds are strong bonds. Metallic bonds are strong bonds. The strength of the metallic bond increases as the atomic size reduces. The strength of the metallic bond increases as the atomic size reduces. And you can say that this explains why aluminium has a higher melting point than sodium. That's due to its smaller atomic size. And the smaller the atomic size, the stronger the forces. The stronger the forces of attraction between the atoms. So we are saying that the smaller the atomic size, the stronger the forces of attraction between the atoms. And that explains why if the atom is so small in size, then its attraction to the other atoms is very strong. And therefore, the metallic bond thereof is very, very strong. And that's why we are saying that aluminium has a higher melting point than sodium, because its atomic size is smaller than that of sodium. So as we learned in properties and trends across period 3, the atomic radius decreases across the period. So the atomic size decreases across the period. So the smaller the atomic size, the stronger the metallic bond. So we'll have an assignment. So the first question, what is metallic bonding? Number 2, use a diagram to illustrate metallic bonding. And 3, state 2 physical properties of metals. So we are going to stop there. Until the next time, goodbye.